Okay, this is problem pass-off sheet number 7. This pass-off sheet is due March 8th. And what we're doing in this pass-off sheet is finding the area and perimeter of certain shapes. So I've given you four different shapes, and we're going to find the perimeter and the area of each. You may want to just draw yourself some different shapes and practice some. We've also got those in the book. On I think it's chapter 8. Let me flip there in the book. Chapter 8, sections 1 and 2 have some other examples if you'd like to try those out. What we're doing for perimeter, a perimeter is just like a fence. So if I were to draw a fence along here, all around my edges, how much fence would I need to buy in order to fence all that area in? Okay, so that's what perimeter is. So in a parallelogram, which this is, the 20 is also right here, and the 11 is also right here. Now the 9 there doesn't help you with the perimeter. It's going to help us with the area. We need to know the true height when we try and calculate the area of the parallelogram. So just for our area, or for our perimeter, we're going to go 20 feet plus 20 feet plus 11 feet plus 11 feet. And so when we add all of those together, we get 62 feet. Now, the question is, do I need to do like a squared or a cubed or anything like that? I don't. When we're talking about perimeter, we just are talking about linear feet, and so nothing changes. When we get into area and volume, that's when we need to start talking about squared and cubed. Okay, so we found the fence that needs to go around, or our perimeter. Now the question is, what do we need to do for area? An area of a parallelogram and a rectangle are the same. It's base times height. And the reason why this is I can take this triangle right here and I can cut it off and tape it right here, and it makes me a good looking rectangle. So all I need to do is times the base and the height together, and it'll give me the same answer whether it's a parallelogram or a rectangle. So I've got 9 times 20, and 9 times 20 is 180 feet. Now the question is that squared or cubed or anything? It is squared. If you think about it, when I have, let me just draw a box over here, and we'll call it a 3 by 2. So I have 2 spots here, and I'm going to have 3 spots along here. Okay, so 1, 2, 3. And what these do is create little squares. Okay, square here, square there, and it gives me 6 squares. So when I multiply these two, it gives me 6 square whatever, my unit squared. So in here, if I were to draw this out, I'd have like 20 lines this way and 9 lines this way, and it would make 180 squares. So I put feet squared. And that's how I remember. You guys can remember however you'd like. Anyway, that's usually the way I get around that. Okay, the next one we've got here is a trapezoid. Now there's a couple of different, well, I mean there's lots of different trapezoids, but this is one that you may not think all the time as a trapezoid. We usually think of a shape looking like this as a trapezoid, but this one's one as well. What we're doing, first off, for our perimeter, is we're just going to add all 4 of our sides. So I have 7 plus 6 plus 7.34 plus 8.2. And so my perimeter is going to end up being 28.54 meters. Remember, we're doing perimeter, so we don't need to square or cube our units on that one. Now, when we go to do our area on this, it's a little tricky, but not too bad if you remember what I talked about in class. What we're going to do is we're going to make this top just a little bit longer, and we're going to make this bottom just a little bit shorter, and we're going to make ourselves a nice little rectangle. Okay, and if I draw it correctly. There we go. So we've got ourselves a nice little rectangle. Now the question is, how do we do that? Well, we just need to take an average of the top and bottom. And now to get average, we add and then divide by the number of things that we added. So I have 6 plus 8.2 and 6 plus 8.2, and then we're going to go ahead and take that and divide it right there by 2. And the question is, why by 2? Well, because I had two items that I added together. So when I divide that by 2, I end up with 7.1. And so what I'm saying is, in this rectangle that I just made, that the bottom here is 7.1 and the top is 7.1. And what I did was make the 6 a little longer and the 8 a little shorter, and then we no longer have that slanty side. And so when we have a rectangle, all we do is just take our base times our height, and then we're good to go. So I have 7.1 times 7, which gives me 49.7 meters squared. Remember, when we do area, it creates these little squares because I'm timesing 7.1 this way, I'm timesing 7 this way, and I end up with these squares in here. And these happen to be square meters. Okay, let's look at the triangle. The triangle combines a piece that we've done before with something a little new with our area. Oh, I didn't want to erase that part. Oh, shoot. Okay, so in our triangle, we are going to... There we go. Okay, we're going to... let's do the area first, okay? When I do the area, I'm going to go area equals base times height, okay? And you say, hey, well, isn't that the same as a rectangle? Yeah, because it is a rectangle, right? If I just draw this part over here and draw this part over here. In fact, let me just do it all in one throw so when I turn it around you can see it. So I'm going to draw this angle piece here. I'm going to draw up and over. Okay, so that makes a rectangle. So when we go 6 times 8, we get 48. Now, we don't need all of 48, but how much of it do we need? Well, check this out. When I flip this triangle back over, look at that. It's exactly the same. So we only need half of it. That's all. So what we're going to do is just take half of that. So what we do is we take and times it by 1/2, or you can divide it by 2. Either way is the same answer. So I'm going to go ahead and divide by 2. That gives us 24 units squared, right? There's no units on this. So when there's no units, you just write units squared. Okay, so all I did was go base times height, just like a rectangle, and then I divided by 2, or times by 1/2, and that gave me my area. And just like I showed, we only need half of a rectangle, which is why we divide by 2. Now, when we talk about doing the perimeter, if you guys will recall, let me draw this over here. Area equals 1/2 base times height, or base times height divided by 2. The same thing. When we do the perimeter on this one, you're going to have to bust out the old Pythagorean theorem, because we have two sides, but we're missing the third side. And you'll recall, when you have two sides of a right triangle, you can find that third side by using the a squared plus b squared equals c squared formula. And you'll recall that that was on our think it was on first terms pass-off sheets, if not on second. So the slanty side, the hypotenuse, the side across from the little square here, is always C. So let's just plug in 6 and 8 in here. So we've got 6 squared plus 8 squared equals C squared. 6 squared is 36. 8 squared is 64. And then we just add together our 36 plus our 64, and that gives us 100. And that gives us C squared. The problem is we don't want C squared, we want C. So to unsquare C, we take the square root of both sides. Now remember, square root is not the same as dividing by 2. So don't try and divide 100 by 2, that won't work. So C squared turns into C, and if you do 100 squared on your calculator, you'll get 10. So this C right here is 10. Is that my perimeter? No. I need to add my 10, my 6, and my 8 together to get my perimeter. So I add my 10, my 6, and my 8, and I end up with 24 units for my perimeter. And that is just a coincidence that they are the same there. Okay, so we've got 24 units squared for our area, 24 units for our perimeter. This is one that I love to give on the pass-off day. So if you will be prepared to do the Pythagorean theorem, that would be a good idea. Okay, last one, we've got this circle. The circle has two different formulas, and they don't call the perimeter of a circle perimeter. They call it circumference. And the circumference of a circle is 2 times pi times r, or pi times the diameter. Now, when we talk about radius, radius is just from the middle to the edge of the circle. Diameter is all the way across. So the 2r is essentially just turning the r into d, right? Because half of it times 2 would be all the way across. So this formula is really designed for diameter. If you only have the radius, then you times it by 2, and then you have the diameter. So when I want to try and find the circumference of this circle, I'm going to go ahead and use diameter in this case. So I will use this line right here because it's the most convenient. I got everything marked off on it. I go 1, 2, 3, 4. So my diameter in this case is 4. So my circumference equals pi times 4. I'm just going to use 3.14 for pi. You can use your pi button if you'd like. So my circumference, or my perimeter of the circle, all the way around the edge, okay, happens to be 12.56. And I didn't put any units on here again, so we're just going to say units. Okay. Whoops. Apparently my InterWrite did not like that. There we go. Units. Alright, so that's my perimeter, or my circumference in this case. The second thing I need to find is the area. And now the area is all the part inside, right? So we found the part inside here, found the part inside here, and inside here. So now we're going to find the part inside of our circle. Now the formula for that is area equals pi r squared, or pi diameter divided by 2 squared. And so you can see this formula is very much designed for having the radius, just like the other one was very much designed for having the diameter. So what is my radius in this case? Once again, I'll just start in the middle and I'll count over to the one side, and my radius is 2. Okay, so I just need to plug it in. I'm going to plug it into this first formula because it's really made for radius. So area equals pi times 2 squared. 2 squared we know is 4, so we have pi to the 4th, and then, or not to the 4th, but pi times 4. And we end up with the same answer we had before, which once again is a coincidence. This does not always happen. For some reason, when I made this problem, I happened to end up with units squared. I happened to end up with two answers that were the same on both these problems, which is kind of crazy. That usually does not happen. So anyway, make sure we're squaring our units on that. So that's it for area and perimeter.